In this video, we're going to look at the antiderivatives of the inverse circular functions. Now, if we have the integral of 1 on the square root of a squared minus x squared dx, the antiderivative of that is inverse sine x on a plus c. We saw, we've dealt with inverse functions before, and we've seen that the domain of the sine function for some restricted interval made the function 1 to 1, and that its codomain then becomes the domain of the inverse. So if you have sine x, you have f, whoops, here we go, f is a map that maps the closed interval minus pi on 2 to pi on 2 into the closed interval minus 1, 1, where f of x is sine x, then the inverse sine x has domain this and codomain this, okay, the opposite. Okay, so for f of x is sine x, that mapping from minus pi on 2 to pi on 2, that closed interval is mapped to the closed interval minus 1 to 1. The inverse sine x, is then a mapping of the interval minus 1 to 1. It becomes the domain of inverse sine x, and to minus pi on 2, pi on 2. Okay, well, transforming, in which case then the antiderivative inverse sine x will be 1 over, and there'll be a 1 where the a is here, 1 squared, just 1, minus x squared. Okay, but if we now transform that by that 1 on a factor, we perform that dilation, that transformation by multiplying the x by 1 on a, then we change the domain of the inverse sine function from that minus 1 to 1, we change it to minus a to a. All right, so that's all that's happening there. Okay, likewise for the antiderivative of minus 1 on the square root of a squared minus x squared is inverse cos x on a plus c with domain x from minus a to a. The integral of a on a squared plus x squared is inverse tan x on a plus c, where x belongs to the reals and not the restricted or limited range that we've seen for this sine and cos. All right, now let's have a look at some examples of that. Okay, so the integral, for instance, of 4 on 9 plus x squared can be written as, we can take that outside, 4 over 3. Okay, we're playing a trick here where we're going to multiply and divide at the same time to remove something. So let's factor out the 4 and let's put it over 3, so 4 over 3, and then put a 3 up here, which means that we can now convert this to 3 over 3 squared. 9 is 3 squared plus x squared, and the antiderivative of that will be 4 over 3 times inverse tan x on 3 plus c. Now, next one, integral minus 1 on the square root of 1 minus 9x squared. Okay, again, a little bit of factorising will help us here. This looks like cos. It looks like this second one up here. Okay, so what we'll do is we'll leave the minus 1 there. What we'll try and do is factor out the 9. So we'll take that underneath the square root sign, underneath the radical there, we'll have 9 outside of 1 on 9 minus x squared. Okay, and we can then write that, well, we can take the 9 right out in that case, that becomes 3, so we have minus 1 over 3 here, and we have the square root of 1/3 squared, okay, which is 1/9 minus x squared, okay, and then we can apply straight out, we're able to apply this second rule at the top here. So we have 1 on 3 inverse cos x on 1/3 this time, 1/3 in there, remember this is the a value here. So I'll put a 1/3 there, and that gives us 1 on 3 inverse cos of 3x, the argument 3x, plus the constant on the end. Okay, another example. This one here. Yeah, that should be about it. The integral 1 on the square root of 16 minus 5x squared. Again, same thing. Let's factor out the 5. Okay, next line down, that'll give us 1 over the square root of 5 when we take it out from underneath the radical, from underneath the square root sign, and we're left with 16 over 5 minus x squared. And we can write that as 1 over the square root of 4 over over square root 5, all squared, minus x squared. We have this factor of 1 on the square root of 5 out front, so that remains there, 1 on the square root of 5 times inverse sine x on, and here's our value, here's our a value, 4 on square root 5, okay, plus a constant on the end. And when we tidy that up, rearrange that, we have 1 on the square root of 5 inverse sine square root 5 times x on 4, okay, plus c on the end. And that is the end of that one.